Right, we're looking at the graphs of sine and cosine. We've got the function f, which is the graph of sine, and we've got the function g, which is the graph of cosine. We want to look at the parameters a, k, p, and q, and we want to see what effect will they have on the graph. So we want to sort of understand what happens when we change these parameters. And we're going to start with a. We just want to have an idea, what does a do to the graph? And a, of course, is the amplitude, and we've set it at 1 initially. Now I want to play an animation to allow you to see what happens when the value of a changes. Now look at it starts with a going down, and you can see the graph stretching in the vertical direction. And of course, if it goes beyond 1, again it stretches. So what a does is stretching. But another thing that it does is when it changes the sign, is to change the graph, or is to reflect the graph about the x-axis. And perhaps we should stop the animation and allow you to see this effect without it moving that fast. So we look at taking it up. You can see it has stretched, and what this does is to increase this is now the minimum value is -2 and the maximum value is +2. And what has happened is the range of this graph has gone from being -1 and 1. That's what we had initially. If we look at this, was -1 and 1, and now when we go up to 2, it is -2 and +2. So if we go up to 3, the same applies. We'll have the minimum as -3 and the maximum as +3. And what this does is to increase the range now to be between -3 and 3. But I want you to look at what happens at 0. At 0, we have literally no graph. It is on the x-axis, just the line on the x-axis where y is equal to 0. And what this means is we've multiplied this by 0. And because q is 0, everything will be at 0. If q was 1, then we'll have that line at 1. And this is not of no interest to us, because we don't want a graph which is just a straight line. But if we go to -1, you can see what happens to the graph. The b that you see here, the point B, was here before. And what this tells us is that the graph is flipped to such that it is now a negative graph. Sorry, not a negative graph, but it is now flipped such that what was positive has now become negative, and what was negative has become positive. The same applies for the point C. It was here. Now you can see it is here. And again, this shows the flip about the x-axis. And if you remember doing functions, you will know that if we multiply a function by a negative, it will flip about the x-axis, and this is exactly what has happened here. And when we continue, what happens, it stays like that, but now it stretches, as we have seen in the case of positive a, and it stretches in the same way. So that is what a does to the graph, and it's important for you to have a picture of this. It will affect the stretch of the graph, which of course affects the range of the graph, but it also, when it changes from positive to negative, it will flip the graph about the x-axis. So whatever that was above the x-axis will be below, and whatever was below will be above the x-axis. That is a reflection about the x-axis.